Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will go through nonlinear equations. So firstly, let's understand what I mean by a nonlinear equation. Well, we've just been looking at linear equations, things of the form like, 2x plus 3 equals 13 or x over 7 minus 9 equals 21. So the reason that these two are linear equations is that they only involve the four basic operations of multiplication, division, subtraction, or addition. So we're going to look today at equations that involve an additional operation, that being powers, raising a number to a power, and we're going to solve those equations. So can we think of an example where we've used an equation in class that has a squared in it? Well, that actually happens quite a lot. Let's start off with a really basic one. So let's say we were finding the area of a square. And remember, a square, four-sided shape, all right angles, all sides equal. If I call the side length s, the area is s squared. So what if I told you that the area of the square was 64 centimeters squared, for example, right? What would be the side length? Well, we can solve that through an equation. You can probably figure it out off the top of your head. But using an equation, we have s squared equals 64. So we can solve this equation using similar principles than we've been using all throughout the topic. We undo everything that has been done to the variable we're interested in this case s. We undo everything that's been done to it. So the way we undo squaring is square rooting. Squaring and square rooting undo each other in exactly the same way multiplication and division undo each other, in exactly the same way addition and subtraction undo each other. So if you take a number, square it and square root it, you're back to where you start. Like 9 squared is 81, you square root 81, you're back to 9. Same with multiplication and division. If you times a number by 9, then divide by 9, you're back where you started. So to solve s squared equals 64, I can square root both sides. So the square root of s squared is just s. So that means s is the square root of 64, which is 8. So if the area of a square was 64 centimeters squared, the side length would be 8 centimeters. Now, some of you are probably thinking, okay, that was so easy, could have done it in my head. Okay, let's look at a more complicated example now. So let's have a look at this question here. The area of a circle is 80 meters squared, and we want to find out what is the circle's radius. Well, we know that the area of a circle is pi r squared, right? We know that because we did it in term 2. So we're told that area is 80, so I'm going to take this equation. The only thing I'm going to change is replace a with 80 because I'm told the area is 80. So I want to find out what r is. So I'm going to use the same principles. I'm going to undo everything that's been done to r. Now, it's important that we understand we still have to undo things in the opposite order to BIDMAS. Now, remember in BIDMAS, the first thing was brackets. The second thing, the I, is indices, which is raising to a power. So this r, what I've done is I've squared it first. The squared part comes first. Indices comes first in BIDMAS. Then I've times by pi, right? So to solve it, I need to not square root first. I divide by pi first. So 80 divided by pi, which is a little over 25. That's what r squared is. Now, I just want to write it as 80 over pi. I don't want to go to my calculator and get the answer of 80 over pi because that is irrational. It goes forever. I don't want to round it here. Otherwise, my answer at the next step will be inaccurate. So now I've got 80 over pi is r squared. The way I undo squaring is square rooting. So r is just going to be the square root of 80 over pi. And I want to write it like this on my calculator. I don't want to write it as the square root of 25 point blah, 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 because that would be slightly inaccurate. I just want to put exactly this on my calculator, and you should get the answer to 2 decimal places of 5.05. We rounded up because the third decimal place was 6. So if the area was 80 meters squared, the radius would be about 5.05. That should be meters. Okay, so we can solve equations, even those that have powers. I'm just going to do one more example. So let's now look at another equation you might come across when doing measurement. So this equation, 4 over 3 pi r cubed, is how you find the volume of a sphere with a given radius. The radius is just the distance from the edge of the sphere to the middle inside the sphere. So that's how you find the volume. So let's say the volume was 200. So if 200 equals 4 over 3 pi r cubed, what would be the value of r? So we're going to solve this equation using the same principles, undo everything that's been done to r. So what I've done is I've raised r to the power of 3 first. That comes before multiplication due to BIDMAS. Then I've times by pi and times by 4 over 3. So let's undo those things. First thing I'm going to do is divide each side by 4 over 3. The astute of you will realize that that's the same as timesing by 3/4. So I get 150, 4 over 3's cancel out, equals pi r cubed. So this is very similar now to the previous example. Again, I have to divide by pi next, because timesing by pi comes after raising to the power of 3. And I have to do things in the opposite order to BODMAS. Now I've got r cubed equals 150 over pi. So the way I undo cubing, raising to the power of 3, is cubed root. And you have a button on your calculator that does that. So r will be the cube root this time of 150 over pi. So for example, the cube root of 64 is 4, because 4 is the number that you times by itself 3 times to get 64. Cube root of 27 is 3, because 3 times 3 times 3 equals 27. So this is saying, what number do I times by itself 3 times to get 150 over pi? And if you put that on your calculator, you should get the answer of about 3.63. So again, we've used a non-linear equation, non-linear because it has a power. The thing we want to find has been raised to a power. And we've just undone everything in the opposite order to BIDMAS to arrive at our answer. All right, hope you've enjoyed this video. This has been the luckiest maths teacher in the world. Have a great day.